that 4p?
Yes.
times-
Yes. 4p times x minus h. Remember the p has to do with the focus of directrix? Remember that?
Kind of sort of almost been like that.
So, like I was saying a little bit ago, and just reiterate, we've done all of those equations without the h and the k. So everything that we've grabbed so far with the circle, ellipse, hyperbola, and parabola have all been at the origin. So there was like, in reality, there was a 0 in the h and k spot. So now we're going to remember that h scoots moves, translates the graph left, right on the x-axis horizontally, and k up and down on the y-axis vertically. So we're going to graph those things that we've been doing all week long and last week now, but they don't necessarily have to be at the origin anymore. So that's what all that stuff is telling you. Okay, everybody, you about got it there, Tom?
We got this.
All right.
Hey, the last one did the same thing as the one right above it, just a 977.
It's all over.
And the a square minus b square. Is
I'm glad you paid attention.
On the hyperbola vertical, is the y minus k squared, is that square
Ooh,
supposed to be?
It's supposed to be on the outside. Thank you. See if I can find my mouse to change. Oh, change that.
And the A squared and the B squared are supposed to be the way that.
I believe so. There we go. Alright. So, 2 quantity squared plus y plus 3 quantity squared equals 9. Our directions ask us to graph it. So I'm gonna get an axis drawn real quick.
So is R the radius?
Don't tell all my answers yet, that's something we're fixing to discuss. Good catch though there, sir. Alright, so first question I'm just getting ready to ask you, Christian's already all over, is what are we gonna be graphing? What's that the equation of? So I think you can eliminate parabola immediately because both variables are squared, and on parabola only one of them is. So that leaves you with circle, ellipse, and hyperbola. Hyperbola is a minus sign, so we're to circle and ellipse. Y,
It's written like so.
do what?
So it's written like so.
It looks like the circle 1Y.
It doesn't have an equal sign until then.
Well, the ellipse doesn't have an equal sign till then either.
It's also not fractions.
Yeah.
Okay, but that's good. So we got all whole numbers, and so that would mean if we're looking at a circle that our radius would be what? You said it earlier.
A whole number.
What whole number?
3.
3. Because this is equal to r squared, so my radius would be 3. What would the center of this circle be?
2, -3.
Very good. 2, take the opposite signs, 2, -3. That's why in those formulas it said minus h and minus k, because you're always going to take the opposite. Okay, so start graphing my circle. I'm going to go 2 units right, 3 units down, and that's the center of the circle. Okay, now when we did circles, I don't remember if it was earlier in the week or last week, after we had our center at the origin, so then we just counted our radius everywhere from the origin. Where am I going to count my radius from this time?
The origin.
2, -3.
Right, I'm going to count from the center. So this is the middle of my circle, so I got to go up 1, 2, 3.
No, I think the origin is middle.
1, 2, 3. 1, 2, 3. 1, 2, 3. And that will be our circle. Let's see if I can do a circle.
That's a sharp circle.
What makes a sharp circle?
It's got some sharp edges.
Well, I didn't do mine very well. It gets a cheat and use the drawer, so just go around it. And I'll end up having, where I can't keep up with my marker. And mine's got some sharp edges too. Alright, everybody good? So graphing circles not any more difficult when it's off the origin or when it's on the origin. So let's look at. I got y minus 3 quantity squared over 4 minus x plus 1 quantity squared over 9 is equal to 1. Directions ask us to graph it. So what is it going to be? What is this the equation of?
A vertical hyperbola.
Okay, it's got the minus sign, and it's equal to 1, so we're a hyperbola. We're vertical because the y's first. Okay, so very good. So to get kind of started, because remember when we did hyperbolas, I like to draw my box. Y'all remember that? So to get me kind of started, I'm going to use my h and k. So this thing, if it's got a minus 3 with the y, that means it's going to be up 3. Remember, go the opposite way of the sign. And then we got an x plus 1, so I'm going to be left 1. We haven't really talked much about a center of a hyperbola, but that's going to help me. That little point there is going to help me get started on my box. Remember where I draw the box and then draw the asymptotes? So now from that box, my y is over 4. So what's the square root of 4?
2.
2. So from that point that I've made, I'm going to go up 2 and I'm gonna go down 2. Now I go back to my little center point. My x is over 9, so the square root of 9 is 3, so I'm gonna go, this is x is left and right, so I'm gonna go right 3 and left 3. So now that gives me where I'm gonna draw my box, my rectangle. I get that bottom one very good. Let me try down there again. Okay. Then once we got our rectangle, then we drew our asymptotes, and so when we drew our asymptotes, whatever day, Tuesday, whatever day that was, we had to cut through the origin. Well, now we're not gonna be cutting through the origin, it's that point we're gonna be cutting through. So I gotta go diagonal and through that little point. Alright, so the last thing I'm gonna do is draw my curves. Now, some people will get confused on this and draw them the wrong way, but Tyler told us this is a vertical one, and he was correct because the Y's first. So my curves are gonna come out of those points that we found there, and they're gonna be vertical, so up and down, so it's gonna go like that. The same thing down here. There you go.
I have a question.
Ask.
Can they ever be like, instead of like this?
With the vertices overlapping, I don't think so. I've never seen one like that.
Can you have like a mixed one where it's, one of them's up and one of them's on like?
I've never seen that. I mean, you could graph more than one function and that happen, but I don't think it would happen with a hyperbola. You know, like you could graph 2 parabolas that overlap like you're talking about, but they would be 2 different functions. Alright, let's look at another one. Give you some different info this time. That is the vertex. Here is the focus. So if I gave you a focus, probably talking about a parabola, we looked at the focus and other things, but this is going to be a parabola. The directions actually tell us that. It says write an equation of the parabola whose vertex is at -2, 3 and whose focus is at -4, 3. So the equation that you copied for the parabola, it's either x minus h squared equals 4 times p times y minus k. But we gotta figure out, let me just draw a little rough one so we can figure out if it's gonna be horizontal or vertical, so we know which one we're looking at, okay? So my vertex is -2, 3. Okay, then, so options on that, it could make a U from there, it could make an N from there, it could make a sideways pointing towards the left, or a sideways pointing towards the right. But then they told me my focus is at -4, 3. 3, 4, so that's the focus. When we did these parabolas like this last week, we learned that the focus gets like enveloped by the parabola. So that means that the focus is here, the parabola would have to open this way. Which means that we have a what? A vertical or a horizontal? Okay, so we are gonna plug in y minus k squared equals 4p times x minus h. And that vertex is gonna give us your h and your k. So we're gonna have y minus 3 squared equals 4p times x plus 2. Very good. Now we gotta find a p. No, remember only one of them squared on a parabola. How do you think we're gonna find our p? We could, but it's easier than solving.
Does P stand for anything, or is it?
Well,
just a
p was how we
placeholder?
found both the focus and the directrix. Remember that? So my focus is right here, and that is 2 units away from the vertex, which means my directrix has to be 2 units away as well. So the directrix would be on the y-axis right there. So that distance is your P. So we had a distance of 2, a distance of 2. Now I just need to figure out my P, if that's gonna be a positive 2 or a negative 2.
Since it's opening up to the left, would it be negative?
Yep. So 4 times negative 2 gives us our final answer right there. Now you could, if you wanted to, distribute your negative 8 and do all that, but I wouldn't. Because the way it's written tells you more stuff about the parabola. It tells you, it reiterates what the vertex is, and so that would be more helpful if you gave that to somebody than if you had it written out any other form. Okay, pretty near simple. You good over there? You good? Alright, last thing we're gonna look at. I'm gonna give you 4 equations. Find my mouse. First, we need to figure out a way to make the mouse bigger and easier for me to see.
Might do it the same way you defaulted.
Well, not yet. Let's do these last 4 first. We're not gonna
Kirsten
grab.
probably wanted an excuse to get on the phone.
No.
Well, he figured out how to keep it black, but it's hard for me to see the mouse, where the mouse is when it's black.
Line.
One more. Okay, now first off, there's 4 equations, 4 different functions there. All 4 of those would be at the origin. Okay, do you agree on that? None of them have the h and the k, have anything being added or subtracted in with the x. There's no parentheses on the top with those x's or y's or anything, right? So all 4 of those would be the easy ones like we did earlier in the week and last week. They would just be at the origin. So all I want to know is what each function is. So on this first one, y equals 1/4 x squared. Circle, ellipse, hyperbola, or parabola? Parabola, very good. Only one variable squared. It could be either one, that would make it be either horizontal or vertical, but only one variable is squared. Okay, number 2, circle, parabola, hyperbola, or ellipse?
Circle.
Circle, lost my mouse again, there it is. There we go, there it is. Circle. Okay, what would the radius of that circle be? 5, very good. Number 3, circle, parabola, ellipse, or hyperbola?
It would be a hyperbola.
Hyperbola. What gives that away that it's a hyperbola?
Minus.
The
Instead of
minus
no
sign?
ellipse.
Well, an ellipse doesn't have a minus sign. So minus sign tells you it's a hyperbola, and then what would the last one be?
Ellipse.
It's the ellipse. Very good, very good. So y'all be able to pick those out. Okay,
All this
so,
talk of ellipses reminding me of the first semester of coding.
oh yeah. Yeah. Alright, so let me talk about how weird, y'all know all year long, I've had the worst luck and weirdest time with timing for where everything falls in here, like when test is gonna be and all that type of stuff. So, we only have 1 lesson left in this unit. So, I'm not gonna do it tomorrow. 'Cause if I finish the whole unit tomorrow, we're back straight into a test. So I don't wanna do that, I wanna at least have 1 unit so we can talk about math some more. So I think tomorrow, I'm just gonna designate for, and it's not y'all people in here, but in some other classes, designate as a catch-up day for anybody, because it's the end of the 9 weeks tomorrow, so.
And
Anybody that needs to get caught up on anything they can. And then, when we come back the first after spring break, then we'll finish that, unit up. But then we'll do some reviewing and stuff, and so the test won't be until that Friday after spring break. Okay. Sound all right with you, sir? Everybody good? That's happened to us all year long. I just have horrible timing.
I like how you said you were procrastinating on what to do for tomorrow, and you, for yesterday, and you just didn't give us anything.
Yeah.
I like that.
What was this
Smart notebook.
Well, go up to edit real quick. No, I can't see that for some.
No, you don't. You're still recording.
Oh, thank you.
Oh, okay.
That's
Good eye.